Okay, let's talk about reaction rates. Um, First of all, just the reaction rate is how fast a reaction happens. Okay. um, so the main thing we're going to focus on is the things that impact reaction rate, factors that impact reaction rate. Okay. And there's 5 of them. Okay, we're going to go through examples of each one. So number 1 is the presence of a catalyst. Okay, so a catalyst is anything that speeds up the reaction without being used up by the reaction. Reaction not being used up. So in our example a few videos ago, okay, we wrote our catalyst right above the arrow. Okay, that's where the catalyst goes, because that tells you, yes, it's being used, but it's not part of the products and it's not part of the reactants. Okay, so it's being used by the reaction, but it's not being used up in the reaction. Okay, so what a catalyst does, right? This is an activation energy curve. So you have your energy here, and you have your time here. Okay, so let's say your reactants are right here, and you've got to add this much energy in order for the reaction to take place. Okay, so that's the amount of energy that has to be added in order for it to take place. And once it reaches this point, then it's all downhill from there, and it goes on its own. Okay, if you add a catalyst, let's say our activation energy curve is in red for a catalyst. Our catalyst does that right there. You're starting in the same place and you're ending in the same place. Okay, so you start at the same amount of energy here, and you end with the same amount of energy there. But the amount of energy that is required, that space right there, as opposed to that space right there, is a lot less. So it decreases the amount of energy required to for a reaction to take place. So it decreases the amount of energy required to make a reaction proceed. Okay, that's basically what a catalyst is. All right, so second example, or second factor that impacts the reaction rate is the concentration of the reaction, or sorry, the reactants. Okay, so let's assume I put your entire class in the gym, okay, and this is you all. I blindfolded you and told you to walk around, okay? I blindfolded you and told you to walk around. Eventually, okay, you all would bump into each other. Okay, it's a big space, there's people in there, you probably miss each other for a while, you know, pass each other, but eventually you're going to hit somebody, okay? And that's when a reaction happens, okay, when you hit each other, okay? If we increase the concentration of the reactants, okay, let's say we put all of our classes in there, and these are all of you, all right? And I told you to walk around, you're going to have a lot more impacts, okay? You're going to have more reactions here, okay, more impacts here than you would here. So we have less impacts here, okay? And just it's a sheer numbers game. You have way more over here than you do over here, okay? So the odds of you running into somebody are way greater, or much higher on the right than they are on the left. Okay, so if you increase the concentration of the reactants, the reaction is going to speed up. Okay, so this is slower and this is faster. Okay, let's talk about the third way. Okay, temperature. All right, so again, here we have our people in here in our room. Okay, and I told you to just walk. Okay, this is walking. So at room temperature, I tell you to walk. And you're going to have a few reactions. You're going to have a few impacts. Okay, so that's walking. What if I increase the temperature? When you increase the temperature, okay, an increase in temp, an increase in movement. Okay, everything moves faster. So if I tell you the same people, and instead of walking, I tell you to run. Run blindfolded as fast as you can. Well, there's going to be a lot more reactions here, okay? A lot more impacts, okay? So this is faster, and this is slower. The reaction is still going to happen. You're still going to run into somebody, okay? But over here on the right, when you're running, you're going to run into somebody a lot faster, okay, and a lot more often. All right, now obviously we wouldn't actually do this, but it's just a scenario. Okay, the fourth factor is the surface area. Okay, an increase in surface area is an increase in reaction rate. Okay, so increase surface area equals an increase in reaction rate. Okay, so think of it as a cube of sugar. Okay, a cube of sugar gets put into a glass of water, eventually it will dissolve. Okay, as it starts to attack the outside, as the water starts to dissolve the outside of the sugar cube, okay, eventually it will dissolve. Okay, if we took that same sugar cube and broke it up into several smaller cubes, let's say 9, just for the sake of math and drawing. Okay, not my greatest drawings. All right, there's a lot more surface area water to get to, so it's going to dissolve faster. Okay, so it can hit here, 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 all of these surfaces, and then it can also hit inside here. Okay, whereas up here at the top, we could only hit the exterior. Now we have a lot more area to hit and dissolve, so it's going to dissolve faster in the water. The reaction happens faster. Okay, the last one, number 5, is just the nature of the reactants. Okay, some reactants react slower. Others by nature. Okay, some reactants react slower than others by nature. It's just the way it's made. It's the way it's shaped. It's the way it comes into contact with the other reactant. You know, some reactants don't react at all. So it doesn't matter how much you put in. You know, it doesn't matter how much you put in there. It doesn't matter how you increase the surface area or how you increase the concentration or how you increase the temperature. Some things are just not going to react. It's not going to happen. So sometimes the nature of the reactants just takes over, and it either happens fast or it happens slower. It doesn't happen at all. Okay, so that is reaction rates. Okay, and the main thing to look at here is just the factors that affect reaction rate.